Students, the second part of this question is asking us to get the sum of the infinite number of terms of this geometric sequence. And the first part is well done. We've just confirmed that the k we had been given initially to prove that it is, in terms of the constant we have in this arrangement, is really 5 over 2 or 2.5 as per what the question has told us. So we want now to get the sum of an infinite number of terms of this geometric sequence. The first thing to do is this. We need to actually ask ourselves, what are these first three terms? When we always have to use this k in terms of substituting in these three terms given in this sequence. So I'll first just be able to pick that k, which is 2.5, then plug back into these terms in terms of where there's k and get the exact values of those three terms. If I can proceed and be able to get the sum of the infinite number of terms in this sequence. So I'll first be able to have 3, of course, raised to 4 into my k is 2.5 plus the brackets minus 5, that is comma, then 9 raised to 7 minus 2 into my k is 2.5. Then the last one is 3 raised to 2 into my k, 2.5 minus 1. So we can tailor down and be able to get the exact values of what we have as our first three terms of this sequence. So you're going to have 3 raised to, that is 2.5 times 4, that is 10, 10 minus 5, that is 5, so 3 raised to 5. Then we shall have 9 raised to, that is 2 times 2.5, that gives us 5. So 7 minus 5, that is 2, so that will be 9 raised to 2. Then comma, then we shall have 3 raised to, so 2.5 minus 1, that is 1.5. 1.5 times 2, that is 3. That will be 3 raised to 3. So this translates into 243, and this is 81, and this is 27. So the good thing is this, we have gotten 3 terms of that geometric sequence, but now they want us to get the sum of an infinite number of terms of this sequence. And of course, we were told previously that the sum of n number of terms, that seems to be a very specific value and not an infinite number, should be obtained by saying a into 1k minus r raised to n over 1 minus r. This is normally used when r is greater than 1. Of course, that means r, our common ratio, is bigger than 1. So you can say sum of that n number of terms where r is bigger than 1 is equal to a, the first term, into, so this is our a, let me write it well, a, the first term, into 1 minus r raised to n, then over 1 minus r. We can't begin with r if r is bigger or r is smaller. So that means we are going to have here, let me just do it so that you can be able to conform to this. So r raised to n minus 1, then here r minus 1. Okay, and in case you want to get the sum of n number of terms of a particular geometric sequence, you can also be able to say a into 1 minus r raised to n over 1 minus r. And this works well if r is less than 1. So that when r is less than 1, then that means 1 is bigger than r. We can begin with 1. But here r is greater than 1, we can begin with r. So when r begins, then the ratio must be greater than 1. If 1 begins, then that means r must be less than 1. But now, if you want to get the sum of an infinite number of terms for a particular geometric sequence, you're going to say, so sum of infinite, and not n number of terms. So this means sum, this means number of terms. If given, they can ask you, find the sum of the first 20 terms. So n can be 20. See, the sum of the first 15 terms. But this is infinite. It does not give us an exact number of terms to actually get. Consider infinite. Of course, to a particular endless point. So it will be a over 1 minus r. This is the formula. N stands for the first term. And our first term is 243 over 1 minus r. I told you how to get R. You can take this term over this, or this over this, and the answer must be the same. The same. So I can just pick any. I can just say 27 over 81. Someone else can say 81 over 243. The answer must be the same. So this translates into 27 there once, 27 there 3. So our ratio is 1 over 3. So you can transfer that ratio here, that is 1 over 3. Okay, so that translates into 243 over, that is 2 over 3. Yeah, 1 minus a third, or 3 over 3 minus a third. So the final answer is going to be, so we shall say 243, of course, divided by 2 over 3 translates into times 3 over 2. So that is going to be, let me just get back to this point. So we have 243 multiplied by 3 over 2. So this translates into, that will be 9, that will be 12 to carry 1. Then that is going to be 6, 7, so 729 over 2. And someone can further simplify that and be able to get, that is 36 translates into 72. Then that is going to be 4.5. If I am not wrong, because I know 2 into 7, that is 3. So that is 6 minus, okay, now 1, 12, 6 into 9, 4, 8, and the 1. Okay, this becomes our final answer.